From manual to automated, the rise of robots in microchip manufacturing. Welcome to Tech Dream Gear, your ultimate hub for uncovering groundbreaking technologies and futuristic trends. In today's episode, we're delving into the fascinating transition from manual processes to automated systems in the world of microchip manufacturing. Robots are no longer just assisting, they're taking center stage in this technological revolution. Grab your tech gear, get comfortable, and let's explore how robots are redefining the production of microchips. The backbone of modern technology. Why microchip manufacturing matters. Microchips, or semiconductors, are the cornerstone of virtually every electronic device we use today. They power our phones, laptops, cars, medical equipment, and even the space industry. As demand for more powerful and efficient chips skyrockets, the industry faces immense pressure to innovate and scale up production. Enter automation and robotics. This video explores how the microchip manufacturing industry has evolved from manual processes to cutting-edge automation, highlighting the role of robots in this transformative journey. The traditional approach to microchip manufacturing. Before the advent of robotics, microchip production was labor-intensive and relied heavily on human skill. Key stages included: 1. Wafer preparation. Silicon wafers were manually handled, cleaned, and prepared for processing. While effective, this method was prone to contamination and inconsistencies. 2. Photolithography and etching. These processes required high precision, but manual oversight often led to errors and wastage. 3. Assembly and packaging. Technicians manually assembled and packaged chips, which was time-consuming and limited scalability. While these methods were groundbreaking in their time, they struggled to keep up with the increasing complexity of modern microchips. The advent of automation. Automation in microchip manufacturing began as a response to the limitations of manual processes. Early robotic systems focused on repetitive and precision-driven tasks, including 1. Material handling. Automated systems ensured that wafers were transported and aligned with micrometer accuracy, reducing contamination. 2. Precision machining. Robots equipped with advanced sensors and AI executed tasks like etching and doping with unparalleled consistency. 3. Testing and quality control. Automation revolutionized chip testing, enabling thousands of chips to be analyzed in minutes, ensuring consistent quality. The modern role of robots in microchip manufacturing. Today, robots are at the core of microchip production, handling tasks that demand extreme precision and speed. Their roles include: 1. Wafer fabrication. Robots execute photolithography, chemical vapor deposition, and ion implantation with nanometer accuracy. 2. Assembly and packaging. Automated arms precisely assemble and encase chips, ensuring durability and reliability. 3. Real-time monitoring. AI-driven robots monitor production lines, identifying defects and optimizing processes in real time. 4. Resource management. Robots optimize material usage, reducing waste and environmental impact. Benefits of automation in microchip manufacturing. The shift to robotics offers numerous advantages. 1. Enhanced precision. Robots achieve levels of precision unattainable by humans, ensuring higher quality chips. 2. Increased efficiency. Automation allows 24/7 operation, significantly boosting production capacity. 3. Cost savings. Although initial investments are high, automation reduces labor costs, minimizes errors, and cuts down on material waste. 4. Scalability. Robots can quickly adapt to new chip designs, making it easier to scale production for emerging technologies. Challenges of automation. while automation offers substantial benefits. It's not without challenges. 1. High initial investment. Building automated facilities requires significant upfront costs, which can be a barrier for smaller manufacturers. 2. Skill gaps. The shift to robotics demands a workforce skilled in AI, robotics, and advanced manufacturing systems. 3. Complex integration. Integrating robotics into existing production lines can be technically challenging and time-consuming. Success stories in automation. 1. TSMC's automated facilities. Taiwan Semiconductor Manufacturing Company leads the industry with highly automated fabs, delivering cutting-edge chips for global tech giants. 2. Intel Smart Factories. Intel's investment in automation has streamlined production, reduced costs, and enhanced chip performance. 3. Emerging innovators. Startups are leveraging automation to specialize in areas like AI chips and quantum computing components. The future of robotics in microchip manufacturing. The integration of robotics in microchip production is only the beginning. Future trends include: 1. AI-driven robotics. Robots will leverage AI to self-optimize, predict maintenance needs, and improve production yields. 2. Sustainable manufacturing. Automation will focus on reducing energy consumption and waste, making chip production more eco-friendly. 3. Quantum chip production. As quantum computing grows, robots will play a critical role in assembling and testing quantum components. A new era of microchip manufacturing. The rise of robotics in microchip manufacturing represents a monumental shift in the tech industry. This transition from manual to automated systems is setting new benchmarks for precision, efficiency, and scalability, paving the way for the next generation of technological advancements. Thank you for watching Tech Dream Gear. If you enjoyed this exploration of robotics in microchip manufacturing, don't forget to like, subscribe, and hit the notification bell. Stay curious, and we'll see you in the next episode.